good afternoon, everyone, and thank you for joining this webinar on understanding and unlocking the potential of cloud computing and artificial intelligence to improve utility service. My name is Kira Zeidelman. I'm a senior manager with the NARUC Center for Partnerships and Innovation. Next slide, please. So first, just a little bit of background on NARUC. We are a nonprofit organization founded in 1889. We represent state regulatory commissions in all 50 states and U.S. territories, as well as the District of Columbia. Our member agencies regulate electric, natural gas, telecommunications, and water utilities. Next slide, please. And the Center for Partnerships and Innovation, myself and my team, we are grant funded, and we are dedicated to providing technical assistance for NARUC members. We identify emerging challenges and connect state commissions with expertise and strategies. We work across multiple topic areas, including infrastructure and technology modernization, electricity system transition, critical infrastructure, cyber, and resilience, and other emerging issues. So with that, I will pass things over to our moderator for today. We have with us District of Columbia Public Service Commission Chairman, Willie Phillips. So Commissioner Phillips, go ahead. Thank you.
Thank you, Kira. Thank you so much. Hello, everybody. Thank you for joining us today. I will admit, I'm so excited and I cannot hide it today. You are in for a treat. I have to say, we're here to talk about understanding and unlocking the potential of cloud computing and artificial intelligence to improve utility service. So you have really some great speakers and presenters that are going to talk to you today. We're in for a treat. You have their information, their bios, with the webinar information, so I don't want to go into great detail, but I will introduce them very briefly. First up, we have Heather Feldman. She is Director, R&D at the Electric Power Research Institute. Welcome, Heather. Now, then we have Rick Cutter, who is the founder, managing director of Cloud for Utilities. And last but certainly not least, we have my friend David Victor, who is a non-resident senior fellow, foreign policy, energy security, and climate initiative at the Brookings Institution, and professor of international relations, School of Global Policy and Strategy, University of California, San Diego. So with that, we only have an hour. I don't want to waste a moment, so we'll jump right into our questions. And I'm just gonna go straight to Heather, because I want you to help us set the lay of the land here. According to the MIT Technology Review, no industry can afford to ignore artificial intelligence. So we're in our industry, in the utility industry. Can you help us understand what is artificial intelligence?
Absolutely. Chairman Phillips, thank you so much for the invitation to participate on the panel today. I'm really looking forward to the discussion with my fellow panelists. And you've asked a really great question. When I think about artificial intelligence, I think back to a quote that I heard. And the quote is, AI is the new electricity. And it's a quote from Andrew Ng, who's a professor, a leading researcher of AI at Stanford University. And he goes on to say that 100 years ago, electricity transformed almost everything. And today, artificial intelligence is positioned in the same way. So if we look around us, from our cell phones to how my daughter uses a calculator, for example, AI is absolutely everywhere, but it's not new. The term was coined at a conference in the 1950s, but the secret sauce that we have today that unlocks the power of AI is really threefold. We have computers that are able to store the data and do the calculations. We have software for the masses versus just having software that a super expert could use. And third, we have the data. So that's really the secret sauce that's unlocking the power of AI for us today. AI has superpowers. It's really good at automating tasks and is really good at understanding large amounts of data that we have today. So there's no real single definition of AI that's out there, but one way to think about it is computer systems that are able to perform tasks that mimic human cognition. It's all about the computer adapting versus simply doing what it's told. So that's how I describe AI.
Okay, Heather, that was a great answer. And you've really mentioned a lot of things that I think we're going to try to unpack during our discussion today. So I thank you for giving us that level set for AI. Now I want to turn to Rick. You come to us as a cloud computing expert, and all of you, I know you very well, so this is going to be a great time. Can you tell us just generally, what is cloud computing for the uninitiated? What does it mean?
Sure. In regards to cloud computing, it's been around for a long time, different flavors, different aspects of it. And I would say in around 2012, 2013, it started becoming more prevalent as Amazon Web Service and those folks started deploying those types of technologies. Back in the 50s, 60s, we would have called it time sharing, where in essence, I don't have to have that technology infrastructure at my location. It's in a third-party location, and I'm in essence renting a piece of that hardware, that network, whatever it may be. Without going into a lot of crazy detail, now the technology vendors have come up with all different forms and slices and dices, and there are things called SaaS, which is basically, instead of buying software, renting software based on some measurable metric for an ongoing agreement, usually by user for a 5-year kind of contract.
That's great. I've never heard anyone put it that way, that it's like time sharing. That's a great analogy. Just so you know, I'm still in that. You hear it again, I took it, okay? David, help us pull some of this together now. So you've done a lot of research and writing in this area. And I'm curious to know, how are we using AI in the utility industry, and how does that really compare to how it's being used in other industries? And tell us a little bit about your work that you've been doing.
Yeah, well, thank you very much, Willie. It's really a pleasure to be here and to contribute to NARUC. NARUC's is a phenomenal institution. I sit on the advisory council of EPRI, and I learned so much from the 10 NARUC members on that advisory council about how you're dealing with the utility industry, the kind of frontier issues, and how that shapes the future of the industry. So I really appreciate the 10 members you send and the institution. So I'm going to focus on AI, and the panel here is about AI and cloud computing. And I think Rick's description of cloud computing and kind of the ski condo, basically, that's exactly right. And I think one of the reasons why that's very important, but plausibly less transformative than AI, is because we can see how reducing computing costs, reducing software costs, and so on lead directly to benefits that we know how to think about and why we would want those benefits and what the risks might be associated with that and so on. And there are new risks. The Russians are listening in. There are new risks associated with this, but they're not outside the pale of what we're used to thinking about. Whereas AI is different, precisely because it allows you to do tasks that you really couldn't do before without huge armies of people thinking about the problem. And even then, what's really good, as Heather said, what it's really good at doing is finding patterns in complex data sets and complex causal relationships that would be hard for humans on their own to find. And so it's extremely powerful. And I think just a couple last thoughts kind of in this first speed round. I think the utility industry is not that far along, and that's for totally understandable reasons. Regulated industry, we're risk averse, all for good reasons. And so already we're using AI a lot, probably we don't know it. We're using it in back office functions, some predictive maintenance, things like that. And we're kind of learning how to do more. But in that sense, AI is unlike innovations, say larger gas turbines or more efficient solar panels, where once you see the innovation, kind of what it's going to scale up and what it's going to do. Whereas what the real potential in AI is things that are hard for us to comprehend right now, like how to do better better modeling and simulation of the grid with large volumes of renewables and large decentralization of power sources and demands. where current tools aren't doing as well as they should be doing, and AI could help us a lot on those kinds of tools. And so it's that next frontier that where you can imagine all the things that you could do, but nobody's quite doing it yet, that I think is the real potential for AI. And in that sense, we have to really emphasize what we don't know rather than what we know.
So David, excellent point. In fact, this is a great segue into what I want to talk about next. You mentioned moving into that second tier. I think as regulators, that's really where we want to focus. We want to know, if there are going to be investments, it's all about who pays for a lot of us. We want to know, what are they and what good are they for us and our consumers? So my question is, and I want to reference how Harvard's, almost said Howard, I got Howard on the mind. Harvard's Frank Wolf says that although AI is in its early stages of implementation, it is poised to revolutionize the way we produce, transmit, and consume energy. And so I just want to open it up to everybody. Like, how do you respond to that? Is Wolf right? Is it going to revolutionize our industry?
I guess I'm happy to, yes. I don't know, yes or no, or maybe. I think it's in the electric space, it is plausibly going to completely transform how we manage complex systems, where situational awareness and predictives are very, very important. So that's the stuff that AI is really good at. My guess is that it's going to give us less insight into how humans make complex decisions and a lot of other human behavioral things, where most of the AI systems are not going to pass the Turing test. This kind of famous test. If you had a conversation with the machine, would you know it's a machine or a human? And I wonder sometimes. But my guess is that in those kind of large data set modeling questions, that it's going to be very transformative. And I think this has big implications for regulators, because we have, as society, and therefore regulators acting on behalf of the public interest, have an interest in those kinds of technological frontiers being pushed, but we don't know what the outcomes are. And so I think you're going to see in the markets that try and do the most, you're going to see regulators creating, in effect, like regulatory sandboxes, delimited areas where there's authorization, if you like, for utilities and for vendors to do things with guardrails, so that nobody takes down the grid inadvertently, and then mess with stuff and learn very quickly what works at scale and so on. Because the real applications of AI are like these technologies, where it's like a little bit like deployment of battery systems, where everyone imagines it's going to be transformative, but actual transformation requires understanding in context, not in the abstract, but in the real context of how the technology gets applied, what works, what doesn't work, exactly what time of the day does it work, and if you eat eggs for breakfast, does it not work, and on and on and on.
So Heather, we're going to drill down a little bit more. So can you talk a little bit about the practical applications? Are you seeing anything in your research that utilities are actually putting AI or cloud computing to work to benefit consumers?
Yeah, we are. We absolutely are. And, I think about AI revolutionizing what we're doing in the context of the digital transformation that we have going on, as well as the clean energy transformation. So in the context of the digital transformation, there's this idea of going from, paper work orders to paperless work orders that are all on the backbone of a wireless network. There's this concept of instrumenting a pump at a power plant, such that pump, just like your car, that pump tells the engineer, hey, I need something's wrong. A bearing is having an issue. You need to come take a look at what's going on. So, and all of that data is going to be connected up with artificial intelligence, and that artificial intelligence is doing those calculations to provide that engineer the information that they need to make a decision. And when I think about the clean energy transformation, and going back to what David was just saying, today it's a challenge out there called learning to run the power system. EPRI's a part of this, Google's a part of this, LTN in France, or LTE in France is a part of this. And the idea is to use the same technology that was used for the computer to beat the best AlphaGo player, to beat the best Go player. That same technology is built into learning to run a power network. So it's basically gamification of the grid. So AI is out there, it's being used. It's being used in applications where we're beginning to understand the technology, and it's only going to grow and move forward from there.
Excellent. I want to turn to Rick. So Rick, David actually said, I'm going to put words in his mouth, but it seems like he said that cloud computing is a no-brainer. It's something that the utility industry should be doing, and they can see the value in it and the benefits in it. So I want to ask you, do you agree with that? And what do you see as the practical applications of cloud computing?
Sure, I do. I mean, I think cloud computing is a no-brainer in regards to the benefits. As an industry, I think we're still struggling with some of the policy and regulatory issues to make it easier for utilities to deploy that technology when it comes to rate of return, which that's a whole other topic we may get into later. But I think what's going on is we've been talking about a lot of buzzwords over the last few years, big data being one of those buzzwords, the ability to integrate multiple systems into making decisions. I think where AI is going to help us, and whether you call it machine learning, sort of a flavor, maybe the little brother of AI, but I'm seeing where utilities are doing things where they're taking large volumes of data, many times on some sort of cloud server because it expands. They're integrating multiple sources of data internally to the utility and also through third-party providers. So an example would be that I think people are doing today would be maybe commodity pricing in their energy trading business, where they're taking demand profiles from their current data and augmenting that data with weather information, building information, how's the housing market doing, which is a lot of data to consume, and making smart decisions on buying and selling energy. So I think that is one application, and there's others as well.
Yeah, and if I could just comment briefly on that, exactly.
Please.
So this is the two last comments are really helpful because being able to play Go very well or play chess very well requires learning a bunch of things inside a known set of rules. And I think, and the same is true for using machine learning or kind of broader, woollier notion of AI for doing market trading, is that as long as the rules stay the same, then you're great. And but the age-old problem of something changes fundamentally that you don't recognize. We went through this with the CDO drama, where there was not situational awareness except for a small number of people who were kind of, in some sense, unable to talk to other humans, and so they had this situational awareness. There was not good situational awareness of how the rules had changed in terms of correlated leverage, and therefore the markets blew up in ways that nobody predicted with the normal stress tests. And so we got to be. This is one of the things we have to be really careful about. Is when we look at advanced computing techniques right now, there's like a set of lights that go on, and we say cyber. We're going to worry about cyber. We're going to worry about the Russians. We're going to worry about a 12-year-old in the basement, and we think about those problems, all of which are real problems, especially the 12-year-olds. But it could be that actually the bigger risks have to do with the overconfidence you get that the machine is able to learn in an environment where the rules are potentially changing, and therefore the demand curves are shifting in ways that are not kind of in the original learned set.
Now, the risk is something that is a great point to bring up, David. Thank you so much. And it's something I want to get everybody involved in talking about. In particular, you talk about, everyone has mentioned data. Everybody has talked about how important data is to this discussion. And so could you all just elaborate a little bit on why data is so important? And then what are some of the concerns? What are some of the risks? David mentioned cybersecurity. I know for cloud computing in particular, and I'll go to you first, Rick. Is cloud computing, is that something that can help us meet our cyber risk and confront cyber threats? Or how do you view it? How do you talk about security in cloud computing?
Sure. Well, it's usually one of the biggest concerns or objections that a utility or any other business may have about putting critical business systems, outside of their four walls at their location, their homegrown data center. But our belief is, depending on who your partner is, and if you look at the firms that have these cloud solutions that they're selling, they're very focused on their business survival to be able to maintain those systems and protect them. So my opinion, our organization's opinion is, if you're XYZ utility with limited resources, it's probably more cost effective to go with a third party that's their core business to maintain that data protected from a cyber perspective. Does that mean that there's not going to be hacks and breaches? One of our speakers last year, Stephen Bernard, former executive for Sony, when they were hacked by North Koreans, his opinion is pretty simple. It's going to happen. It's how do we protect ourselves and recover? It's very difficult for a business or a single organization to defend themselves against a nation state attack. So it's a big, complicated issue. We're going to have to get better on it. It's got to be on top of our radar, all of us as consumers and as businesses.
Heather, David, security concerns? Do you agree with Rick?
Yeah, I think so. I think that's right. I mean, Sony also had the benefit of offering the North Koreans all the juicy, ridiculous things that their executives said about the stars. So that was attractive. I think that's right. I think in that sense, this is I won't say this is a conventional problem, but this is a familiar problem. And I guess just to be a little repetitive, my concern is dealing with the less familiar problems. And I think those are going to present themselves to an even greater degree in the AI space than they do in the cloud computing space, unless, we get to the next one here. I'd really defer to Rick, get to the kind of next wave of cloud computing where you're not just renting space, but you're actually off-site, but you're actually integrating more of your in-house functions with functions that are off-site, not just kind of passing something in a back office kind of a way. Then you could imagine synergistic properties of failures in the off-site, failures in the on-site having bigger dangers that are unfamiliar.
Since I'm a regulator and I'm not expected to know much about this topic, I can say ridiculous things, and I'm going to say one right now. And we joke a lot about things. Rick and I have talked a lot about, like Skynet. Regulators may or may not have realistic assumptions about what AI, and you mentioned machine learning, what these things can do. I mean, are we headed to a world where something like that is even in the far off possibility?
I'll answer with a couple of analogies. I was talking to a friend of mine the other day, and I like the Skynet, and I like if you remember the old movie with Matthew Broderick, War Games, we had the Whopper controlling the nuclear weapons, and it was an AI in essence. But if you think about artificial intelligence, we're a long way from that today, but it's really programming, and it's based on using large volumes of data, hopefully, that gives it a good data set to make decisions. But an analogy a friend of mine told me the other week was, imagine as AI continues to persist, and there's a bridge and there's a barge. The bridge has an AI with its goal is to keep traffic moving as smoothly as possible, right? So cars can go over that bridge going into DC, and then there's a barge with an AI that says, keep going, full speed ahead. We're going to have to continue to evolve the programming of these things to understand different aspects of technology so that they don't conflict. And I guess that would be part of the Skynet analogy. How do we make sure that doesn't happen? I think it'll be an evolution also where it goes from giving us good information to automatically making decisions. And I guess that would be the Whopper analogy where, in that sci-fi movie, it automatically, based on its own self-awareness, would launch the nuclear missiles, right? So I think we've got a long way to go before we get to that, but we're going to see incremental improvements in AI to make good decisions, and hopefully smart people in business will be making the final call on whether to implement that decision.
All right, so we're disappointing everybody who thought that we were going to have Terminators operating our power system in the near future. So Heather,
well, if there are people who thought that, then I have a bridge just to continue the technology.
Well said. Well, I mean, Heather, like before we move on from the practical application, and I want to get into some other things like ethics and other questions, just real world, like think about high voltage transmission. How can AI help or benefit the folks running the system at that high voltage level?
So when it comes to transmission, that's an asset that is so important to the grid. It was built starting, in the 1940s or something like that. And it's so critical to our power system, how we get electricity. So some of the work that EPRI's been doing over the last couple of years is related to asset management. So what we've done is put together machine vision, so image analysis, and then we're collecting, curating a large data set of insulators that have defects. And we're training the AI system to automatically detect a defect of an insulator that's a photo that's taken by a drone that's flying over the transmission line. So that's just a great example of how artificial intelligence can automate the analysis work, and then ultimately the human's still making the decision based on the information that the AI tool is providing. So it's out there being used today in a few places.
You know, you think about some of the huge outages that we've seen in recent memory. A lot of those were human error. A lot of them involved things like vegetation management, and you mentioned using drones and things like that to help us manage our boat power system. I think that's great, and something that I think regulators should be aware of as we talk about this stuff. I appreciate you raising that. I'm going to shift gears now. Okay, part of our job as regulators is to look out for our people, for our consumers, and part of that is ethical considerations. So we're entering into a new realm with AI and cloud computing. Are there any ethical concerns that regulators should be aware of or concerned with? Now, kick it to David.
I'll start. I mean, the list is not short, and we don't even need Hollywood scriptwriters to help us, but even they'll help us here. I think we need to, let me make two comments. One is a comment about understanding the downside, the real tails in the distribution, and the more complex the system, and frankly, the extent to which humans don't have real deep understanding about how the system behaves, which in some sense happens to an even greater degree, the more machines you put inside the system, the greater we don't really understand what the tails look like, especially when the tails are the result of synergistic effects of lots of different systems. And so it's quite possible that we'll actually get much better at avoiding kind of simple outages, for example, squirrels, conductor failures, yada, 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 where we know how to frame the problem, but that the big outages that are the result of interactions of systems could remain, plausibly even get worse. I mean, that's just, so we have to, so one of the big ethical issues, which is also a performance issue, is being able to understand what the horizon really looks like. This is why public interest research, the type that EPRI does, for example, is so important, where we work with real systems, but we're looking at a different question from the question that an individual utility or an individual market would be looking at operationally. So that's one set of questions I think that'll be important. The other I'll just mention is we have to remember that the frontier of computing here is moving out, not just for the utilities, but also for everyone else inside the society. And that means that the same kinds of capabilities will exist, are democratizing, if you like. The 12-year-old in the basement who has nothing else to do now has enormous AI capabilities that in principle allow you to take lots of data sets from which you could not glean personal information and glean a lot of personal information. And so we have to have the capacity, in some sense, it's going to err in the direction of privacy at a time when intellectually and politically and so on, we're moving in the opposite direction. I'm very worried about that.
Yeah, I like the analogy you used about the frontier and how it's moving out, and it's moving out for everybody. I have to say, I think for a lot of folks, they're not paying as much attention to the privacy concerns as they probably should. I mean, I'll tell you even myself, and this isn't related to AI necessarily, but I'll go to a Starbucks and log into the Wi-Fi that's available, and I don't know what the privacy implications of that may be. A very simplified way to look at privacy, but taking a step back again to get back into the stream of our conversation, are regulators paying enough attention to this? Are there concerns? Go ahead.
Can I just put note to that? Yeah, I knew that you went to Starbucks though, because my phone's AI system already.
It's tracking you.
Yeah, I'm tracking it.
No judgment. We're in the friend zone. No judgment.
Well, the pumpkin spice latte in January, that was an error. But I think this is an area where the NARUC world would gain a lot from talking with your European colleagues who are now very well, are NARUC'd. They're very well organized. They're very effective. And the European privacy rules and data protection rules are further along than our rules. And so we would learn a lot from having a focused conversation with them about this.
I want to bring Heather into this discussion. Is EPRI focused on the privacy issue?
So from a EPRI perspective, we're conducting independent research and development for society. We have this amazing membership base that trusts us, and we earned their trust over many, many years. And they've shared their data with us. It's been said that we get a year's worth of operating experience in a day for our nuclear power plants, for example. So this wealth of information. But, I'd like to think about it as the analogy of we're chefs running a farm-to-table restaurant. So we know the people that we're getting the data from. We have that relationship. They know us, they trust us. We understand what that data is. And, with that farm to table analogy, we're very, very particular and careful with how we treat that information. We have a data intake process with all of the legalese that goes along with that. We have a data governance process. We bring it in-house, we secure that data. So we've got a very thoughtful process in how we're treating, concerns around privacy. There might be some cases where we're using the data for an analysis and nobody wants to share plant names. And so we need to make sure we have that in place to where we can do that. Other cases, it might be this data is available to the public and we can share it more broadly, but we are absolutely very careful in how we take care of the data. And like I said, we're chefs at a farm-to-table restaurant.
That is very, very reassuring. Thank you for sharing that. So Rick, I want to come to you, and I want to change the conversation a little bit again.
Sure.
It's not lost on anybody here that we're almost at a year now of dealing with the global pandemic. Some places have been dealing with it, if you're talking international, more than a year. But we've been working in this sort of remote posture, at least at the commissions, since March. And so my question is, what, if any, impact has COVID-19 had on the cloud computing? And if you want to, touch on a little bit the AI conversation.
Sure. I don't know that it's had a direct advancement, if you will, of AI. It's on its own track. But I do think that the COVID situation where we all had it seems like the week of March 16th, everyone I knew all of a sudden was working at home. For whatever reason, that was the big week. And a lot of utilities that we work with all have told me that we had this system, that was a SaaS model. So very quickly, we were able to mobilize and get our employees home, even our IT employees. Other folks that were not in more of that cloud model for different applications had to set things up to create technology to allow people to remote in and VPN. So they had a little bit longer curve to do that. Hindsight, a lot of utility CIOs that I talk to are telling me that it's accelerating the move to different cloud products and services. Simply because of the ease of those transactional shifts. Some of the vendors I've spoken with are telling me in the last 3 to 5 months, they're seeing a dramatic increase of requests for information proposals from our utility partners that they're looking for cloud first. So the transition of the recognition of that as a desirable platform, I think it's accelerated due to COVID-19. another, I hate to say a benefit of anything to COVID-19, but I think utilities, because of that, it was like, do we stop this project? Do we stop this business venture we were doing and wait for this thing to end? Or how do we adapt to working on, WebEx and Zoom and Teams and do things remote? Just in my little world of the utilities, I know of about 10 different utility companies that have been implementing ERP systems, and they may have had a little pause as they figured out what was going on, but they went live, they did training completely on technology like this. I think one good benefit we're going to see is that companies will now realize we can work remote effectively, and they're going to save millions of dollars on travel, where these armies of consultants would spend, tons of people where we're just paying for travel for butts and seats to go do work. That's money now utilities will be able to spend on real tangible things for the benefit of the ratepayers.
You mentioned money, Rick, and I think no NARUC panel is complete unless you talk about rate making. So I want to ask you, what are the rate making in your view? The ability to, hey buddy, you see a puppy in the frame.
Sorry, that's Rocky. I should have locked him up. Apologize.
No, it's quite all right. It's welcome distraction from me talking. So here's the question: have utilities cracked the puzzle on how to get compensated for cloud computing?
I think that's probably giving it too much credit, but I do think that utilities are recognizing that if they make the business case and explain it to the regulator, they're able to get some of those costs into the a rate making situation to earn their rate of return. But it's still not very black and white on will the commission for that particular state let them do it or not. So I think there's a little bit more of creative approach to rate making than we probably should have, in my opinion. I think it should be pretty easy. I think everything we do in a rate case is obviously based on the return on the investment to make sure that we're controlling our dollars and spending them wisely. But I don't think it's very clear. I think the Illinois folks went down a path and had a pretty good model defined on how to make that pretty standard, but it got shot down, I think, near the end of last year. It did not get approved. They had some commissioners change, et cetera. But I think we need more work on that is the short answer. And I feel like we're going to have the same thing, the same issue for cybersecurity, right? They cannot make a rate because it's a service. That's not an asset that they can put a rate case on or a rate of return on. And I think investing in cybersecurity, we talked about this earlier, is just getting more and more important, and we need to incent these utilities to do those types of investments.
Well, I just want to piggyback on that and remark that NARUC actually issued a resolution supporting and encouraging commissions to encourage their utilities to invest in cloud computing and to treat it with the traditional O&M, operation and maintenance type cost. So David, jump in.
Yeah, I mean, I think the most difficult questions are going to arise around AI, because it's going to, if it really scales, is going to be the least O&M like and the most asset like, not tangible asset like. And yet it's going to involve backing a lot of things, half of which are going to turn out to be dogs. I guess if you have a good AI system, it'll figure out quickly which are dogs and which aren't. Well, not to disparage Rocky in any way. And,
he's a smart dog.
Okay. And I think that's actually going to be a big challenge. And also, this is going to be opaque to most. I mean, I really pity regulators seeing these cases, because there's going to be all kinds of promises. Silicon Valley's involved, which means that there's a whole bunch of business plans written on napkins with no other data and kind of wild visions. And some of them are going to be right. The problem is you just don't know in the beginning which are. And so I think could be a very important role for NARUC to in some sense help bring together the jurisdictions that do these regulatory sandboxes, so that the whole of NARUC can learn more rapidly where the real value propositions are and where we should think about these things as assets and where we should think about them as pass-through O&M.
Excellent points. Excellent points. And I want to turn to Heather and ask a different question. So, we all are aware that we have the graying of the workforce is an issue that's on the horizon. I think that, sort of the uneasiness in the economy is really, extending the life of a lot of folks in the workspace. They're not retiring as soon as we thought they would. But that being said, we know that many executives are in their, late 50s or 60s, and so they're going to be looking at retirement in the near future. I'm just curious, do you have any thoughts on how AI might impact the workforce, and will it have any impact at all?
Yeah, I absolutely think it will, and I'll start from the perspective of as retirements happen, and I'll say earlier career folks are entering the workforce, they're likely going to be what I'll call AI enabled. In other words, they're going to have an engineer resume, a scientist resume, the next discipline resume, but there's going to be an AI component to it. So they're going to come into the workplace understanding a bit about artificial intelligence, even if they aren't the expert. And already today, I would say AI is a profession. Carnegie Mellon University set up a bachelor's degree in artificial intelligence in the fall of 2018. So on the folks that are entering the workforce, I think we're going to see an AI component, some AI expertise already being there when they come into the workforce. Now, for the existing workforce, I'll say artificial intelligence is going to be used daily. It's probably already being used daily by the workforce, whether or not we know it. I think about, I joke about this. I wandered downstairs the other day and my daughter was laying on the couch saying numbers and I couldn't figure out what she was doing. Well, she was talking to her phone, using her phone as a calculator to do her math homework. So AI is around us. It's in the computers that we have in our pockets. It's in our cell phones. It's in the way that we interface with our work today. So it's there. We just don't know about it. We don't recognize it as AI.
Rick, David, is this true? I mean, is it baked in already, or are we going to notice an impact when AI really starts to hit its stride? I mean, are we going to be replaced? Is the question.
I mean, the nature of work is going to change, but that's in that sense, this is part of a larger trend, right? There'll be returns to people who have skills and not as great economic returns to people who don't have skills. And you see that already in wage levels, and you see that in economic disparity in the country and so on. And it's a huge challenge for the country, and we're not alone. So in that sense, people are not going to be replaced, but they're going to be doing different jobs. They're going to be overseeing things more than actually doing all the machinery. They're going to be like airline pilots. So bad coffee, difficult schedules, but overseeing computing systems, basically doing a lot of the work. So I think, and that actually should be welcome because done well, this creates a quality of work that's higher and more engaging in the brain and has all these other benefits from that. But it has to be done in a way that's seen as inclusive, lest we see politically in this sector and other sectors the same things we've seen in the rest of the economy, which is a lot of people feeling left out from this and organize now vehemently in ways to try and block that, and that's not good for the society. It's not good for political stability, and it's ultimately not good for the broad public mission that the regulated enterprises are supposed to advance.
You touched on a good point. I had this conversation at it's a similar conversation. A lot of us deal with transportation, and HBO, they have a special, it's called The Future of Work. And there's a scene where they have a truck driver who, tough guy, right? I mean, he's talking to the host and they're talking about, automated driving. And he's like, I'm not worried about that. It's not going to impact my career. And then they put him in the cab and they take him on a hour-long drive down the road. And when this guy gets out of the truck, I mean, he's weeping. He's in tears because at least for his small part of the picture, he knows that it's over. It's over. So it's a valid concern, I think, for people to have. I think it's comforting to know that there are thought leaders like yourselves out there who believe that this isn't the end, that it's going to lead to a higher level of work. But just coming from a real place with real people, I just want to say I get it. So look, we have about 10 minutes left, and I want to leave time for people to ask questions that are watching. One of the things that I want to talk about, though, is decarbonization. And we've all talked about this a lot, and Dave, you've done a lot of research on this issue. When it comes to AI, when it comes to cloud computing, Rick, is there a pathway? Will this help jurisdictions like mine that's looking to go to 100% renewable energy? How can AI help? How can cloud computing help?
Well, I mean, precisely because you're trying to decarbonize by doing all renewables. So, you know, there's a frankly a little bit of a disconnect, not a little bit, there's a huge disconnect between the energy modeling folks who are, and all of the above in the decarbonization sense, lots of options, especially as you on the electric power system, and then the politics, which are really very strongly favoring renewables or renewables heavy solutions. And so my guess, as someone who studies the engineering and also studies the politics, is that compared with the ideal engineer solution, that the human solution is going to be one that over renewabilizes, and the extreme case is 100% renewables. I think renewables are an ideal example where grid predictives will benefit enormously from the capacity to use AI tools to understand how large complex systems actually behave. And so this actually could be a huge benefit to the renewables revolution.
Anybody else want to weigh in on the decarbonization issue?
I think it'll be a multifaceted approach. If you look in theory, if we move more computing to these cloud solutions, you know, they're big data centers burning a lot of power, right? And most of those larger firms, however, have a plan for renewable energy to offset their carbon footprint that is significant. And as we do more cloud computing, we're taking some of that energy consumption from individual businesses and transferring to those guys. So I think that is just a small piece of the pie, but I think it's going to have to all add up for these, you know, 100% goals are not going to be one solution.
All right, so we have a question from the audience. My screen is so small here. I'm gonna ask Kira, can you read the question out for me, or can you come on and read it?
Certainly, and I'd like to encourage the audience to continue asking questions for the remainder of our time, so please go ahead and submit those. This first question is going back to the conversation about regulatory barriers and cost recovery. It seems as though there's a bit of a chicken and egg problem when it comes to cloud investments. Addressing regulatory barriers to the cloud may not occur until utilities start making significant cloud investments, but those investments aren't being made because of the regulatory barriers to cost recovery. How do we draw real proactive attention to this issue and make progress here?
Well, I think it has to be handled at the regulatory level, because I believe many utilities, and that number changes every day, want to invest in those types of technologies for the benefits of their own particular business and, of course, their customers. I think we have to continue to educate NARUC and individual public service commissions on those benefits and help prepare the utilities to offer probably a less technical, you know, business case to explain those benefits. So it's going to be education, 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 in my opinion.
I couldn't agree with that more. Sort of in that same vein, I have a question about, you know, jurisdiction. A lot of this, you know, a lot of the regulatory hurdles, it's a state by state puzzle that we're putting together. So I mean, we know that the federal government recently said they're going to have an office to look at these sort of, you know, issues. Does it make sense, this state by state patchwork? Should there be some federal guidance, regulation? Should this is a FERC DOE issue? Can you help us with that?
I think it would help. As a matter of fact, we're doing a webinar with Commissioner Chatterjee of FERC here in a few weeks, and that's one of the questions I'm going to ask him. They had a couple of things on their roadmap last year to try and make some decisions about virtualization, which is sort of a form of cloud computing, but a decision did not occur out of that to make a recommendation. But I do think we need to do that because the benefits for California are the same as the benefits for DC and New York. So I would like us to see maybe a stronger resolution from NARUC or a follow-up and a national approach for sure. I think that would help us.
So, I mean, I think we've sort of gotten to a point here where we can start to wrap it up. As a final question, and this is going to be a surprise to you guys, but I think you're going to be fine. Look in your crystal ball. Look ahead a decade from now. I mean, if you think about a little over 10 years ago, there wasn't anything like the iPhone, right? So what do you think, if you had to guess, what does the landscape look like with AI and cloud computing? And this will be your final word, so please give any final thoughts that you want to give. And we'll start again, as we did in the beginning, with Heather.
10 years, I tell you what, that's a long time. So, if I think 10 years from now, so it's what, 2031, just saying that out loud says something. So I do think that artificial intelligence is going to be a big part of our world. I do think it's shifting going back to our conversation about the workforce, it will shift how we're doing work such that the computers are doing more of the calculations, the humans are doing less of the calculations, but absolutely the decision making. It's absolutely going to be a part of the digital transformation. It's going to be a part of economy-wide decarbonization as we go forward. The way I look at it is it's a tool in the toolbox for the right problem, but it's going to lead us to a future that's different than today.
Excellent. Rick?
Well, I completely agree. And I think we're going to continue to see more emerging technologies incrementally. I think back to the late 90s and early 2000s. I remember getting this thing called MapQuest, where I could go on my computer and get a map printed out. And when I would travel for business, I had this map, of course, on the steering wheel, not very safe, but it helped me get there. And now I have all these apps on my phone, and I can even talk to it and say, give me directions, like Heather's daughter is doing math. That is some form of AI or virtual assistants. That's going to continue to increase. I think from an energy perspective, we're going to see more and more distributed energy. Solar panels has become, or some whatever the new thing is in 10 years that will be generating energy is going to be more persistent throughout our country and hopefully more cost effective. But I hope it'll keep making our lives easier and improving our quality of life. And to end, thank you for including me, NARUC. I appreciate the opportunity. And Commissioner Phillips, thank you for including me.
Yes, sir. David, close us out, please.
Well, I echo the thanks, and I agree with what's just been said. I guess I'd say two things. One is there are going to be, because of, it's always hard for us to comprehend exponential growth, and many elements of the system are growing exponentially. So in 10 years, there are going to be all kinds of capabilities, and where those capabilities slot into what we know how to do and how to save money, of which I think cloud computing right now has been the most proximate example, that's going to be ubiquitous. And the real puzzle is going to be, why is somebody not doing that? So that I think is relatively straightforward. What's not so straightforward are the transformative uses of AI. So 2031, I believe your jurisdiction, Willie, will be essentially at 100% renewables, and the grid's going to wash the clothes for you automatically, all the other things that you've promised. So that California is going to be 60% and cruising renewables. And so the places that have very high decentralized renewable loads, I think you're going to see some of them using AI in much more sophisticated ways as part of grid management. And my guess is we're going to see a huge variation across the country between some places that are doing that, that are maybe even Hollywood worthy, and then other places where it's still going to be basically stability comes from spinning turbines, and you see some applications of the margin, and things are not that different.
All right. Well, with that, I cannot improve upon it. I want to thank each and every one of you. I think that this was outstanding. I promised that it would be special, and I know that it was. So I thank each of you. I will turn this over to NARUC to have the final word.
Thank you, Chairman Phillips, and thank you to Heather, Rick, and David for your remarks. I thought that was a great conversation. I certainly learned a lot. So I appreciate you all taking the time to speak to NARUC. So just calling your attention to our upcoming webinar schedule. We have a really interesting slot of webinars through the next few months, ranging from data and energy equity to cybersecurity for solar energy. We have a number of really interesting topics that encourage people to sign up.
I think we lost the audio.
I can hear you.
Sorry about that. Am I back? Okay. So I put the links to sign up for our upcoming innovation webinars, as well as the upcoming NARUC Winter Policy Summit in the chat box. So please check out both of those. And with that, I think we will end. So thank you again to all of our panelists. Thank you to our audience for joining us. Have a good afternoon.
Bye, y'all.
Nice meeting you all. Thank you, guys.
Thank you.